Parameters are passed to a function by declaring them inside the parentheses of the function definition and passing them in the parentheses of the function call. Here I have a working copy of func.cpp from chapter 2 of the exercise files. And let's pass an integer to this function. So here if I just say int I, and inside here I can say printf, value is %d, new line I. And down here in the function call, you notice I have this red error which says that there's no matching function for call to func. That's because the function signature doesn't match. We'll cover function signatures a little bit later. But the point is that there's no function that doesn't have anything as a parameter. Now if I need to put in the 42 here, or some integer, in order for this function call to match the function declaration. So now when I build and run, you'll see that it says the value is 42. So this 42 is an integer, and that's copied and passed into this integer for the function, and now the function has its own copy of the integer, which it uses to display the value. Now, by default, functions in C++ pass variables by value, which means that a copy of the value is made, and that copy is used inside the function. That's called pass by value. You can also do what's called pass by reference. And so in this case, I would have an integer here, say, and I'll pass that integer instead of a literal 42. And now up here, I can say int reference I. And so instead of making a copy of the variable, it simply passes a reference to the variable, and that reference is used inside the function. Now, if I build and run this, you notice it does exactly the same thing. But here's the interesting thing here. If I change this value to, say, 73, and down here, after the function call, if I printf x, you notice that x actually gets changed to 73. And the reason for that is that we're passing it as a reference. So this ampersand, that declares this function parameter variable as a reference. And now that reference is simply a reference to the variable that is passed to it. So just as if you were doing an assignment of one variable to another, if the target variable is a reference and that assignment is in the declaration, as we've learned about references in the last chapter, then there is no copy made. It's simply the new variable becomes a reference to the variable that's assigned. That's exactly what's happening here. Instead of assigning a value to this function variable, it's simply a reference to the variable that's passed. And so when I change it inside the function, it actually changes the variable in the caller. Now, as you can see, this is pretty dangerous, and you can have unintended consequences by doing it this way. There are reasons that you're going to want to do that, and we'll cover that in a moment, but you can prevent the side effect by simply declaring this as a const. And now you notice I get an error for the assignment here because it's a read-only variable and it's not assignable. So I just can't do that anymore. And now when I build and run, you notice that everything is still 42. So the compiler will not allow me to change the value of this constant reference. And yet down here, if I want to, I can still change it because this x is not a constant. And there we have it changed. So this is a common technique when interfacing with libraries in C++. Very often, the functions and methods in a library will have constant references instead of variables. This does a couple of things. One, it makes it safe. You know that your library is not going to change the values of your variables. And two, it's actually faster and more efficient in cases where the thing that you're passing is rather large. For example here, if instead of an integer, if I had a string, and I'm going to need my string library up here, we're going to use a C++ standard template library string class. And so down here we'll say string s equals hello, I'm a string. And now we're going to declare our function. Instead of taking an integer, it will take a string reference. We'll call it fs for function string. And instead of printing the integer, we'll print a string. And we'll say fs.cstring. And now we call function with s. We don't have an X anymore. And of course, string is %s, and we can do this. So now we have a function that takes a string reference. Now, this string could be any kind of a large object, and rather than copying, however many bytes this large object is, we're simply passing a reference. And by using the const modifier, we're making that a read-only string, or in language terms, an immutable string inside the function. But outside the function, it's still just a regular class string. And so now when I run this, the value is hello, I'm a string. The string is hello, I'm a string. This is really why references were created for C++, to allow call by reference for functions so that you can pass large objects. Before references, this all had to be done with pointers. So instead of func_s like this, or a constant string like this, it would have an asterisk and it would declare it as a pointer. And then instead of this dot, we would need to use a pointer dereference here. And when we pass it, we would pass the address of the string. And so this is actually exactly the same effect, but you can see it's a little bit more complicated, and this is why references were invented for C++. The pointer technique is common in C. In C++, you'll almost always see this done with references. So it's important to realize that values are passed to and from a function on a small data structure called a stack. The stack is a small space, and it requires processing power to manage it because it's a data structure. So passing large values to a function requires copying large amounts of data onto this stack, which oftentimes doesn't have enough room and is computationally expensive. So this can be time-consuming, but it can also cause the stack to overflow, which can crash your program and create a security vulnerability. Many of the security vulnerabilities we see these days in the wild are vulnerabilities because the stack can overflow, and these vulnerabilities take advantage of that and overflow the stack and inject code and do all kinds of horrible things. So when you're passing something larger than a simple scalar value like an integer or a long or a double or something like that, you're going to want to use a reference. You're almost always going to want to make it a constant reference. So you'll be using a reference like this, and we'll use the dereference operator like that, and we'll be passing it like this. So this example here is how you're going to want to pass larger values to a function. So by default, function parameters are passed by value in C++. You can pass pointers or references if you need to pass larger values, but you need to do it explicitly.